Welcome back to another lecture. So in this lecture, I'm going to try to introduce electronegativity and also show you how to draw geometry of a molecule. Okay, so imagine we have such a molecule, and it depends whether they are identical or not. When they are attached to each other, one of them might imply, like one of these atoms might imply stronger force. So this is one example. Like the central atom is different than the outer atoms. It depends on the number of electrons that they have and also their size. When you attach them, one of these atoms might apply higher force, or another way to steal technically the electrons, the bonding electrons between them. Okay, so what's electronegativity? Electronegativity is the ability of pulling bonding electrons to yourself. Okay, so when you're attached to your neighbor, if you try to pull the electrons to yourself, that's going to be electronegativity. And electronegativity, we show it by En, and we say En to the right side of the periodic table, it increases. Down in any group, electronegativity decreases. Okay, so for example, if you are talking about element like say we have sodium. Okay, next I go aluminum and chlorine versus sulfur. Okay, all of them belong to the third layer. This one belongs to the third, and third layer. So in that case, because all elements belong to the third layer, we're going to sort them based on their technically number of protons. Okay, this one it has 11 protons, 13 here 17, and sulfur it has 16 in the protons. We say electronegativity to the right side of the periodic table increases. Okay, and we are sharing the same N. Okay, so I'm going to say chlorine with highest number of protons, okay, will have the highest electronegativity, then sulfur. After that one, we will have aluminum, and the least one it will be sodium. So if they are in the same period, you sort them technically based on number of protons or atomic number. Okay, so if I highlight this one, I'm going to call it atomic number or number of protons. Okay, number of protons. Now, what will happen if they are in different periods in the group? So let's say you are dealing with sodium. Next one is I go lithium, and what else? Let's say fluorine. Okay, sodium it has 11 protons. Lithium will be 3. Okay, all right. Lithium it will be 3, and then fluorine it will be 9. Okay, so I go. Okay, and I go. This one belongs to the third layer. Lithium belongs to the second layer, and fluorine belongs to the second layer. Okay, so again, to the right side of the periodic table, electronegativity increases. Down in any group, electronegativity decreases. Okay, so we're going to sort them based on N first. With the one with the smallest N, it will be either lithium or fluorine. Which one has more proton? Fluorine. So fluorine has higher electronegativity than lithium, and lithium is going to have higher electronegativity than sodium. Okay, again, this one is N2. That one is N2. Why? Lithium, because lithium it has 9 protons. Oh, sorry, the fluorine 9 protons. Well, lithium it has 3 of them. How about sodium? Sodium belongs to the third layer. Okay, belongs to the third layer. As you go down in one group, okay, electronegativity decreases. So I go, because N is the third, sodium is going to be the lowest one. Okay, and remember we have lithium, sodium, and then here we will have fluorine. Okay. Okay. Now, when you attach two identical elements to each other, none of them is going to win. So technically, you will not see a difference in electronegativity between them. If they are identical, we say there is no movement with the electrons. And when I say movement, they're not going to be closer or far from one element. And in that case, we call them non-polar. Okay, non-polar. What does it mean? Okay, anytime you attach the two non-identical elements to each other, you're going to have a polar bond. Why polar bond? Because they will have a different electronegativity. Different elements will give you different electronegativity. Okay, so anytime you attach two non-identical elements, you will have a polarity. Now, how strong the polarity is, it depends on the difference in their electronegativity. In organic chemistry, if the difference between, for example, the electronegativity of those two elements is something less than 0.5, we say that's non-polar. Okay, why? Yes, there are different elements, but because the gap is not much, in reality, you're not going to sense it. But for the purpose of Gen Chem, you can call it, like a polar bond. Okay, so let's go with this example. Okay. If I take hydrogen and attach it to carbon, okay, that's going to give me a polar bond, okay, because they are non-identical. Okay, if I take hydrogen, attach it to fluorine, again, that's a polar bond. Electronegativity of fluorine higher than electronegativity of hydrogen. So what does it mean? It means fluorine is going to pull those two electrons to itself. Okay, and what are those two electrons? I'm talking about these two electrons. Okay, that's a sigma bond, okay, and it's made of 2 electrons. Fluorine is going to try to pull those 2 electrons. So fluorine is going to have extra electron technically, and we show the extra electron with delta minus. Okay, how about hydrogen? Hydrogen lost something, so I'm going to put cross on the tail to show that hydrogen is going to have a positive charge. Okay, now I got a molecule that has two poles, okay, positive and negative poles. So I'm going to call this molecule a polar molecule, okay, because it has two poles, a positive and negative poles. Okay. Now, in order to have a polarity, or in order to call the molecule polar, you need to have difference in electronegativity. Okay, you need to have difference in electronegativity. Now, it depends how far, like the difference between those two elements is. You might slowly actually lose the covalent bond and turn it to ionic. So extreme case of covalent bond, it will be ionic bond. In that case, you are not going to have a covalent bond. You're not sharing electrons. You are transferring electron to another element, and that's not a covalent bond. Remember, covalent bond is sharing two electrons between two elements, not transferring them. Okay. Now, again, we said that if the difference between them, the difference in electronegativity between two elements is like 0.5, less than 0.5, we call it non-polar. Okay, non-polar, because it's going to be so hard to sense it. It's not like it's not a polar bond. Yes, you have a polar bond, but it's not significant. You don't feel it really. Okay, when do I start to feel that polarity? Okay, when the gap between the electronegativity is 0.5 or like a higher, 0.5 or higher. Now, if you pass 1.7, the gap is bigger than 1.7, you're not going to have any sharing. One of the elements is going to be so strong that it will take those two electrons, it will steal them. In that case, you are not going to write minus delta or plus delta. You will say +1 and -1. The +1 and -1. For example, when you take sodium and you pair it with the chlorine, sodium is going to give electron to chlorine. And this is going to happen. Sodium will have a positive charge, and the charge is a whole positive charge. How about chlorine? Forgive me. Chlorine will have a negative charge. In the negative charge, it will be a whole negative charge. Two particles with opposite charges will attract each other. The reason sodium is close to chlorine is not because of the bond between them. There is no bond. It's an electrostatic force. Two particles with opposite charges are going to attract each other. Okay. Next subject is the Lewis structures. Okay, and that was like the subject that actually you covered or you went through it in chapter 10, I believe. Yeah, chapter 10 and 11 of Chem 13-14. Okay, so I have some data here about Lewis structures, but I want to show you some slide that I use them for Chem 13-14. Okay, let's start with this. Okay, first one is, what's the octet rule? Okay, octet rule. It says if you have elements like carbon, nitrogen, and oxygen, fluorine, give them 8 electrons. Otherwise, they will not be stable. So let's make it as a note for ourselves. Anytime we have nitrogen, carbon, oxygen, and fluorine, we need to make them octet. If not, system is not going to be stable. Now, remember, we are going to share electrons with our neighbor. Okay, and if you are carbon, because you have 4 electrons, you share it with 4 neighbors, you will get 4 electrons, so you will have 8. I have 4, share it with 4, and I will have 8. But if I'm beryllium or boron, okay, and because I will have only two or like 3 valence electrons, I can make it octet, or I can meet the 8. Okay. Or if you have element that has d orbital, that element is capable of passing the octet rules. It doesn't mean that they have to follow the octet rules. No, they can go further and technically make more than 4 bonds. Okay. Anytime they make 5 or more, that means they pass the octet. Octet means 8. Okay. So let's practice how to use these rules and to draw Lewis structure of any element. Okay. Start with this. Okay. So we have, for example, we have a molecule like CH and fluorine 3 times. Okay. Now you want to get Lewis structure of this, Lewis structure of this molecule. Start with this. So first step, find valence electrons. Valence electrons. And remember, carbon is a group 4, hydrogen group 1. Okay, or first column. Fluorine It's a group 7. That means it has 7 valence electrons. So what you're going to do, you're going to say, I see 1 carbon, 1 hydrogen, I see 3 fluorines, and then say this, minus charge. Okay. Where is the charge? The charge is supposed to be here. Okay. No charge. No charge means charge equal to charge equal to 0. So no charge means charge equal to 0. So I'm going to say 1 multiply 4 electrons for carbon, 1 multiply 1 electron for hydrogen, and 3 multiply 7 electrons for each fluorine. Minus, okay, what's the charge? Is 0. So we don't care about that one. I get 21 plus 1 plus here 1, 22, 26 electrons. We got 26 electrons. Next, sort them based on electronegativity. Okay. Sort based on electronegativity. And ignore hydrogen. Okay, ignore hydrogen. Okay, so what I'm going to do, I have only carbon and fluorine, and I'm going to say electronegativity of fluorine is going to be higher than electronegativity of carbon. Okay, electronegativity of fluorine higher than carbon. What does it mean? It means this. It means carbon is the central atom. Carbon is the central atom. And how many electrons do we have? 26. So write the 26 somewhere for yourself. Okay, and put carbon in the middle. Now you have hydrogen and 3 fluorines. Put them wherever you want. Okay. Okay, now I'm gonna use 2 electrons to make 1 bond. Okay, so I'm gonna use 2 electrons to connect 2 technically elements. Okay, that's the first bond. Okay, so I'm gonna say minus 2 electrons because I made 1 bond. Okay, and that bond we're gonna call it sigma. Okay, this is the sign for it, sigma. Okay, repeat this one for the rest of the element. So I made 4 sigma bonds. Per each sigma bond, we use 2 electrons. Okay, so I repeat this one 4 times. Okay, 26 minus 8, that's going to be 18. Okay, 18. Now, electronegativity says fluorine has higher electronegativity than carbon. Okay, what should I do with the 18? Next step, you will draw a circle around each element. Okay, so draw a circle around each element, and so I'm going to move this one. Okay, including the central atom. Okay, next, start with outer atoms. Okay, and the one with the highest electronegativity. Okay, right now, if I zoom on fluorine, okay, if I zoom any fluorine, inside the circle, I see 1 electron, and we made 1 sigma bond. So 1 electron is here. This fluorine technically is going to fill this electron and also that one. So it means 1 plus 1, fluorine is filling 2 electrons. We need to make it active. So what should I do? I'm going to give it, okay, I'm going to give this one 6 extra electron to make it active. Okay, so now I see 7 electrons inside the circle. We made 1 bond. That one will be 8. Okay, I use 6 of them, so I'm going to say minus 6. And I'm going to repeat this one for the rest of the fluorines. Okay. Okay, so I repeat this one 3 times, and I'm done. I don't have extra electron. Okay, if you check the fluorines, you go 7 plus 1, 8, 7 plus 1, 8. How about hydrogen? Hydrogen, it has 1 electron, made 1 bond, is 2. So hydrogen is done. Hydrogen, it has only 1 orbital, and it can accommodate only 2 electrons. And that was the reason I said don't include hydrogen here. I said ignore hydrogen when you sort them based on electronegativity. Hydrogen cannot be the central atom. Hydrogen is capable of making only 1 bond. Okay, and because it has only 1 orbital. How about carbon? Let's check carbon. Okay, I see 4 electrons here. So I go 4. We made 4 bonds. And that's going to be active. So everything is active, and that's the Lewis structure of the molecule. Okay. Next thing that I want to practice is going to be the formal charge. Okay, what's the formal charge? Okay. Before we go after the formal charge, let me label some of these electrons. Okay, so those 2 electrons that I pair them, we call them lone pair. Lone pair because they are not attached to anywhere. Okay, but these 2 electrons that are paired between carbon and hydrogen, we use them to make a sigma bond. We call them bonding electrons. Okay, the lone pair, sometimes we call them non-bonding. Non-bonding electrons. Okay, so now let's go after the formal charge. How to calculate formal charge of one element? Okay, formal charge for 1 atom. Okay, so the formal charge is equal to valence electrons of the atom. So valence electrons minus non-bonding electrons, non-bonding electrons, plus half of bonding electron. Okay, half of bonding electron. I need more space, so let me shrink those. Plus half of bonding electrons. And close this one. Okay. So this is the structure that we have. We have carbon attached to hydrogens and 3 fluorines. Each fluorine, it has 3 lone pairs. Okay, let's practice the formal charge for any of them, okay, any of this atom. Okay, and I'm going to start with hydrogen. Formal charge for hydrogen is going to be equal to, what's the group for hydrogen? Hydrogen belongs to the first column, so it will be group 1 minus. Do I see any lone pair non-bonding? No, so it will be 0. Plus, how many bonding electrons we have? We use 2 electrons here to make a sigma bond. Half of them belong to hydrogen. So half of 2 belong to hydrogen, and that's going to be 1 minus 1, it will be 0. 1 minus 1, it will be 0. That means formal charge of hydrogen is 0. Repeat this one for, carbon. Carbon belongs to group 4. So you say 4 minus. Do I see any lone pair around carbon? No. How many sigma did we make? We made 4. And per each sigma bond, we use 2 electrons. So technically, I have 8 bonding electrons. Half of the 8 belong to carbon. So it will be 4 minus 4, 0. Okay. And how about the formal charge for fluorine? Fluorine, you got this. Fluorine belongs to group 7. Okay. Do I see non-bonding around fluorine? Any fluorine, okay? Any fluorine you pick. Okay, for example, number 1, fluorine number 1. Okay. I see 3 lone pair, 3 non-bonding electrons around it. So 3 pairs, technically. 3 pairs means 6 electrons. So I go 6 electrons plus. We made 1 bond, so half of 2 electrons. So it will be 7 minus 7, that's going to be 0. Okay, so I got all the formal charges equal to 0. And if I add them, okay, let's highlight the formal charges. If I add them, answer is going to be equal to 0, and this is equal to charge of CHF 3 times. Remember, this molecule had no charge. Okay, and I got all the formal charges equal to 0. So note, when we add all the formal charges to each other, the total charge must be equal to charge of the molecule. Okay, let me show you another method for finding formal charge. Okay, so another method for finding a formal charge. Remember, we had carbon, fluorines. Okay, 3 fluorines. Okay, I'm going to connect them. Each fluorine had 3 lone pairs. Okay, so another method for finding formal charge. Okay, what you need to do, draw a circle around each element. Okay, next, say this. Okay, how many electrons inside the circle do I see? I see only 1. So I'm going to see 1. Oh, forgive me. Okay, forgive me. Okay, hydrogen is a group 1. Okay, hydrogen is a group 1. So say 1 minus. Next, how many electrons inside the circle do I see? I see only 1. So 1 minus 1, that's going to be 0. Next, fluorine is a group 7. So you will say 7 minus. How many electrons here do I see? Include this one in your calculation. 6 plus 1, that's going to be 7. It will be, okay, 7 minus 7, 0. And you repeat this one for the rest of the fluorines. Okay, how about carbon? Okay, carbon is a group 4. So you're going to say for carbon, okay, for carbon, the formal charge, we say 4 minus. Okay, how many electrons inside the circle do I see? Okay, I see, okay, 1, 2, 3, 4. So 4 minus 4, that's going to be equal to 0.